Here are some problems involving complex number format. If we have 5 plus xi equals y minus 4i, that statement I made about if they're equal, their parts must be equal, the real parts must be equal, and the imaginary parts must be equal, that means that 5 and y must be equal. So we know y equals 5. We also know that their imaginary parts must be equal. So that tells us that x equals -4. Now let's consider operations. Adding. If you weren't told about the fact that these were complex numbers written in a plus bi form, and you were told simply to perform this operation, you might think that they were binomials and add them as if they were just combining like terms. That indeed is exactly what you should do. We'll add the real parts together. 5 plus 4 is 9. And we'll add the imaginary parts together. 6i minus 2i is 4i. So it couldn't be any better if you had invented it yourself. The two binomial-looking complex numbers add real part to real part, imaginary part to imaginary part, just like you'd like to do them. Now let's look at 3 with a subtraction in there. Once again, we're going to look at 8 minus I minus 6 plus 5i plus 1 minus 2i. And so we'll look first at the real parts. 8 minus 6 plus 1. 8 minus 6 is 2, plus 1 is 3. Now let's do -1i minus 5i, that's -6i, minus 2 more I is -8i. Let's check that. -1 minus 5 is -6. Minus 2 is -8. So there we have it. We have combined 3 complex numbers. This one, subtract a second, add a third, and we've gotten a single a plus bi form answer. So we've seen how to add and subtract. It's just combining like terms. In another lesson, we'll consider multiplication and division.